Okay, class, we'll see how this goes for you. We're going to start chapter 13, section 13.1, and our objective for today is we're going to evaluate trig functions. So I need a minute to write those down. Also write down sine, cosine, and tangent. Those are going to be your building blocks or the basics for this entire chapter. Once you get those down, you're going to be set. So sine, cosine, and tangent. Real quick, just to let you know, sine has a partner, and it's cosecant. Cosine has a partner, and it's secant. And tangent is cotangent. The other thing I had you guys write down was tangent off to the side there. So you should have wrote that a second time. And the reason I had you write that is because tangent in another form is sine over cosine. If you notice how I wrote sine and cosine, that's how we abbreviate them. Tangent is also abbreviated TAN. So just to know that sine and cosecant are going to be related, cosine and secant are going to be related, and tangent and cotangent are going to be related. And how they are related are they are reciprocal with one another. So cosecant, abbreviated CSC, is 1 over sine. Secant, abbreviated SEC, is 1 over cosine. And cotangent, abbreviated COT, is 1 over tangent. Now, these are going to make a lot more sense once we get started with the next slide. So we will go ahead and move on. All right, so like I said, we're going to do right triangle trig. The one word that's going to save your life for this chapter, if you can call it a word, is SOHCAHTOA. You may remember that from your geometry classes. SOHCAHTOA is going to help you with all of your triangles. And if you notice, we have, looks like a 0. That's called theta. That's just a measure of an angle. Again, you should have seen that at some point in time in geometry, I would hope. But what we're going to do is we're going to talk about SOHCAHTOA. And the breakdown of SOHCAHTOA is sine of theta, so S is sine, equals opposite over hypotenuse. So that's where the S, the O, and the H come from. Sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. So that's where the A and the H come from. So adjacent over hypotenuse. And anybody care to guess what tangent would be? Opposite over adjacent. Very good, whoever said that. All right, so it's opposite over adjacent. If you can remember SOHCAHTOA, that is, again, that's going to be your basis for this entire chapter. If you remember that, you're going to be in good shape. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. If you remember that, cosecant, we just talked about, reciprocal. Cosecant, you're just going to flip them. So you have hypotenuse over opposite. And it'll be a lot easier when we get to the next example with some numbers. Secant is just the reciprocal of cosine. So it's going to be hypotenuse over adjacent. And cotangent is going to be adjacent over opposite. And like I said, that'll come into play in just a minute here. The one thing you do have to know is the hypotenuse is always the longest side of a right triangle, and it's always opposite of the right angle. So that's the one that is going to be the same every single time. The adjacent and the opposite side are going to depend on what angle you're talking with. If we're looking at theta in this problem, the opposite side is across from theta. The adjacent side is, well, just like it sounds, it's adjacent to theta. If I were to change my angle and put it up on the top, theta up there, all of a sudden, the adjacent side, let's go down over there, the adjacent side becomes the opposite side, and the opposite side becomes adjacent side. So you have to be able to identify the angle, identify the hypotenuse, and do so from there. You'll be good to go. All right, so let's actually take a look at an example with some numbers. All right, it says evaluate the 6 trigonometric functions of the angle theta shown in the right triangle. So notice I give you all 3 sides. This is one of those special right triangles. It's a 5, 12, 13. That means it's always going to be 5 is the short side, 12 is the long side, 13 is the hypotenuse. It gives us those nice numbers, whole numbers, I should say. And the angle we're looking at is right up here, angle theta. So the first one, sine of theta, SOHCAHTOA. Sine is opposite over hypotenuse. So the side opposite of theta is 12, the hypotenuse 13. Cosine is adjacent over hypotenuse. The adjacent side is 5 over the hypotenuse is 13. And the tangent of theta is opposite over adjacent. In this case, opposite is 12, adjacent is 5. Now again, the nice thing about cosecant, secant, and cotangent is once you get sine, cosine, and tangent, you just flip them. So you don't really have to memorize the whole, oh, that one's hypotenuse over opposite or adjacent over whatever. Just flip them. 13 over 12, 13 over 5, and 5 over 12. Any questions so far? Oh, good. I can't answer them because I'm not here anyway. So, but if you need to pause, pause, rewind. That's the neat thing about being recorded. Next slide. We're going to evaluate, same thing, only this time I didn't give you one of the lengths. So hopefully you guys remember from your geometry class or from your Algebra 1 class or from whenever the Pythagorean theorem that says a squared plus b squared equals c squared, where c squared is always your hypotenuse. So in this problem, find the hypotenuse. It's 5 squared plus 10 squared, and we got to take the square root of that. So I got 25 plus 100, and that's the square root of 125. Of course, we're always simplifying in class, so 125 is 5 times 25 is 5 and 5. I got a pair to get out, so it's going to become 5 square roots of 5. So now I have sine is opposite over hypotenuse, 10 over 5 root 5, and we're going to come back and simplify all these in the end. Cosine is adjacent over hypotenuse, in this case is 5 over 5 root 5. And then tangent is opposite over adjacent, which in our case is 10 over 5. And like I said, we're going to simplify those because we can't leave radicals in the denominator, and we also can simplify 10 over 5 will be 2 over 1. Cosecant. Cosecant, let's just flip them. So I got 5 root 5 over 10. I got 5 root 5 over 5. And then we have 5 over 10. So I'm going to show a little bit of side work on one of them. And then, whoop, here went my cell phone. And then we just have to simplify. So I'm going to go over here and do sine. Times root 5 over root 5. So I got 10 root 5 over 25. You can simplify 10 and 25. So that would become, they're both divided by 5. 2 root 5 over 5. That's 2 root 5 over 5. And you guys can go through the same process. I'll do the easy ones. Tangent will become 2 over 1, 2 over 2, so forth, but you guys can go through and simplify all the other ones. Actually, I guess cosine would just be the hardest one because all the other ones are simplify kind of nice. There we go. That is listing the 6 trig functions when you're given the sine lengths. You'll have 6 problems like that tonight, I believe, if I remember correctly. All right, let's go on. Let's talk about special triangles. Special triangles 45, 45, 90, if you guys remember from geometry, 30, 60, 90 from geometry, they were kind of nice because they always gave you the same answer. What we're going to do is we're going to talk about 45, 45, 90 first. And 45, 45, 90, if I let the sides be 1, because the base angles are congruent, that means that the sides are congruent. If I use the Pythagorean theorem to figure out what the length of the hypotenuse is, I have 1 squared plus 1 squared. Take the square root of it. That's the square root of 2. So if you remember from your geometry class, it was always leg times root 2. Well, that's going to come in handy when we figure out the 30 degrees, 45 degrees, and 60 degrees of sine, cosine, and tangent. And then we'll just take reciprocals of those and we get to the cosecant, secant, and then cotangent. So 30 degrees we can't do because we just did the 45, 45, 90 triangle. But we can do the 45. If I let any one of these angles, because they're the same, doesn't matter. If I go opposite over hypotenuse, I'm going to get sine 45 equals 1 over root 2. If I were to simplify that, I multiply by square root 2 over square root 2, and that's root 2 over 2. These are some special ones that you're going to want memorized, or you're going to want to know how to prove the 45-45 triangle and the 30-60-90 triangle. I'll give you a little trick when we're all done filling out the table, because really you only have to memorize the sine of everything, and then if you can do that, then you can fill in the cosine and the tangent because there's a pattern there. So fill in the 30 and the 60. 30-60, if you guys remember, talked about, well, the one length is 2, the other one is 1, and then it was times the square root of 3. I can show you the proof when I get back if you guys want. But for right now, I'm just going to give you the numbers. The hypotenuse is going to be 2. And then the base is going to be 1. And then how you get the leg is root 3. At the end, from geometry class, if you remember, the biggest angle always has the longest side. So 2 is always across from the 90. And if you remember 1 and root 3, 30 is the smaller, or the smallest, I should say. So then 1 is going to be across from the 30, and the square root of 3 is going to be across from the 60. So if you remember those, they go in order 30, 60, 90. If you put the numbers in order, 1, square root of 3, and 2. So now if we go through and actually do the sine of 30, sine of 30. So I'm looking up in the top angle. Sine of 30 is opposite over hypotenuse. That's 1 over 2. And then if I do sine of 60, so now I'm looking at the bottom angle. That's sine of 60 is root 3 over 2. Now, like I said, there's a nice little pattern. So much stuff about trig, I'd love to tell you guys, but we don't have enough time to go through everything. So I'll just give you the gist of it. Cosine, the base co stands for complementary. So what's the complementary of 30? Complementary is 60, so that means that cosine of 60 is 1/2. What's the complementary of 45? Well, that's 45, so it's the same angle. And if we do the complementary of 60, well, that's 30. So then it's going to be root 3 over 2. You're going to get the same answers. Sine of 30 is 1/2. Cosine of 60 is 1/2 because 60 is the complement of 30. Now if I do tangent, instead of going through and thinking opposite over adjacent, I just remember that tangent, you guys wrote it down, is sine over cosine. So now I can just take a look at my numbers and say, okay, tangent is 1/2 divided by root 3 over 2. Dividing by a fraction is the same as multiplying by its reciprocal. My 2's will reduce. I get 1 over root 3. And when I simplify that, you get root 3 over 3. Like I said, when you guys do enough practice, it's going to be second nature for you, so it'll be just fine. So if it's a little overwhelming right now, it's okay, because you're going to have a study hall to work on it tomorrow. If you look at tangent of 45, sine divided by cosine, well, anytime you divide number by itself, it's 1. And then 60, then I have root 3 over 2 divided by 1/2. Divided by 1/2 is the same as multiplying by the reciprocal. 2's would reduce, and you're left with root 3. And I'll be honest with you, I screwed up because I forgot that I had a table on that space of work. So I'm gonna maneuver that stuff that we just did. I'm gonna try to anyway. And then we're gonna talk about filling in all the rest of them. Just here's my table. Now let's see if I can scooch this over. Move all these. Voila. Be good. Okay. And if you guys remember, cosecant, we said, is just the reciprocal of sine. So if I just know that sine is 1/2 when it's 30 degrees, cosecant is 2/1. 45 degrees would become 2/√2. So if I simplify that, it's actually going to become the square root of 2. And then if I do 60, that's going to be 2/√3. If I simplify that, it's going to become 2√3/3. Again, the nice thing about the cosecants and secants, I can just flip these, so this is going to become 2. That's the same. This is 2√3/3. And then cotangent, again, I can just reciprocal all my tangents, so I have 3/3. If I multiply by √3 to show you the word, we get 3/3/3, which is just √3, 1, and this one is going to be √3. Now again, like I said, it's going to be in your best interest to memorize this entire table. But again, if you just remember that tangent equals sine over cosine, and if you remember the first 3 numbers, you're good to go, because everything is based off of the 1/2, the √2/2, and the √3/2. If you forget, you're going to have to make the 45, 45, 90 triangle. And then you're going to have to just fill them in as you go, because you won't have a calculator when you're doing problems that have 30 degrees, 45 degrees, and 60 degrees, just to give you a thumbs up. All right, I believe we have 2 more examples and then we're done. We're going to ask you to solve a right triangle. What it means to solve a right triangle is you have to find all angles and all side lengths. So we'll start with the easiest one first. We'll start with the measure of angle A. Let's hold that meeting with a minute to write it down. While you do that, I'll check and see who sent me a text message. Because technically we're not in class. Like Holland just sent me a text saying the video that Cole Bachmeyer is using for running for state student council president looks awesome, and he's pumped. Just let you guys know. Okay, everybody's got a chance to write it down. Measure of angle A. Degrees in a triangle are 180. I already know that C is 90, so all I have to do is find the complement of 62. So 62 plus what gives me 90 degrees? 28 degrees is the correct answer. Now what I'm going to do is I'm going to find the side length B. So if you take a look, I know side length A. I'll put it both of you. The length of A is 6. I'm going to use 62 degrees, and I'm going to use 6. So if I take a look here, I'm looking at this angle. If I want to find B, I can look at opposite and adjacent. What trig function relates opposite and adjacent? And that would be tangent. So the tangent of 62 equals opposite over adjacent. So in this case, it's b over 6. Tangent of 62, we're going to have to use our calculator. So if you have your calculator handy, this would be the question that's on the calculator portion of the test. I'll go ahead and bring up the TI calculator. First thing you have to do is press mode and make sure that we are in degree mode. So press mode, it's the third one down, change it to degree. Go ahead and press second, click. On our problem, it said tangent of 62 equals b over 6. Again, from your geometry class, I know that you did these because I've helped many people in geometry that always come in asking these questions. I like them because all you got to do is use your calculator. Tangent of 62 is a number. So it's 1.88072645. In other words, I got something that looks like this. 0.726465 equals b divided by 6. Whoops, not b divided by b. That's a 6. How would you solve for b? Well, just multiply both sides by 6. So I come here and say, okay, take that times 6. Ta-da! It's 11 point, and let's go 2 decimal places, so 11.28. So b is approximately 11.28. And that's just a coincidence that it's the same as the degree measure. Now what we have to do is we have to find c. There's two ways of doing it. I'm going to show you the exact way because I don't like using the Pythagorean theorem, but that's also an option. You now know that b is a certain length. You know that a is 6. You can take 6 squared plus 11.28 squared, take the square root of that, and then give you c. I like using all of my trig functions. So I'm going to use the angle 62 again, and now I have adjacent and hypotenuse. So in this case, I'm going to go cosine of 62 equals adjacent over hypotenuse. Now this one's going to take a little more work to solve. Because what I have right now is I have my variables in the denominator. So I multiply both sides by c. I get c times the cosine of 62 equals 6. And then how would I solve for c? If I divide by cosine 62, I get c equals 6 divided by, and then whatever that number is. So if I go back to my calculator, 6 divided by, I can type cosine 62, goes on my parentheses, and it's 12.7. So C is approximately 12.78. So I found side C, found side B, and I found angle A. Everything else was given to us. So we got to find all 6 pieces. Length of A, length of B, length of C, measure of angle A, measure of angle B, measure of angle C. Alright, let's go on to the last problem. We got a word problem here. It says, you measure a flagpole, you stand 20 feet from the base of the pole, the angle of elevation from the point on the ground to the top of the pole is 65 degrees, find the height of the pole. I like problems like this. I remember doing them in college. It's kind of nice. I know that some of our teachers take you guys outside and they use what they call a tonometer, and that measures the angle to a certain point, and then you can figure out how far away you are, and then you can use trig to estimate the height of the building, because you usually don't have to take a measure that goes that high. So if I look, it says you measure a flagpole, you stand 20 feet from the base. So here I am, my lovely artistic abilities, 20 feet away. It says the angle from the ground to the top of the pole is 65 degrees. We want to know, well, how tall is this pole? So I got an angle. Right. I have the opposite side, and I have the adjacent side. Opposite and adjacent, which trig function relates opposite and adjacent. If you said tangent, you were correct. Tangent of 65 degrees equals opposite over adjacent. And again, now it's just a solving problem like we did on the last slide. So if I go to my calculator, punch in tangent of 65, it's 2.14. I go with my cell phone again. So I don't care, I'm not going to re-record because that takes forever. And then I multiply by 20. And the approximate height of the pole is 42.89. I'm popular, I guess. 42. And what do we measure then? Feet. Alright. That is your introduction to trigonometry. plan for tomorrow is you're just gonna have a study hall. So if you wanna work on the assignment together tomorrow, well, oops, nope, I take that back. You're not gonna be able to do that because tomorrow is the testing day for anybody that didn't take it last week. So the test will be administered tomorrow in class. That way people aren't running all over the place trying to find when and where to take the test. It'll just be easier doing it that way. And then when I'm back on Wednesday, if you guys still got some questions, we'll have some time to straighten everything out. So your assignment is page 772. It's 15 to 20, 33 to 39 odd, and 43 to 47 odd. Enjoy the rest of your day, and I will see you on Wednesday.